Hi, in this video we are going to be doing the empirical formula lab involving magnesium, where we will try to be getting some experimental data to confirm the chemical formula for magnesium oxide. So we're going to be starting with a crucible. This one happens to be a new crucible, which will save me a little bit of time to clean it out, but normally you'd want to make sure that it was clean and dry. Then what we're going to do is we are going to heat it over the burner. So I've placed it in a clay triangle, as it's called, and that is sitting on a ring stand. We have our Bunsen burner down here. So to start this, one of the things we've noticed over the years is if your flame is too high, the flame will actually envelop the crucible itself to the point where air won't get in. And that means that you won't get a reaction. So this one is a bit sensitive to the height of the flame. So I'm going to lower that a little bit. And the goal here is to just heat this for a minute and then give it a couple of minutes to cool. And when we determine the mass at the end of the experiment, we want the temperature to be more or less comparable. There is a small lift effect that can be measured on a electronic balance, so we're trying to avoid that type of complication. Because the amount of mass that you're using here is relatively small, so we want to try to avoid any sources of error that we can. So that seems to be probably a reasonable amount of time. Now, if you're lifting a crucible and you're using crucible tongs, there's a method for doing that. You actually want to use the bent portion of the tongs to grip that crucible. So I'm going to set that at the bottom of the ring stand and let that cool for a couple minutes. This is a pretty good choice here because it is made of metal. It does have a little bit of space underneath it, so that should facilitate the heat transfer and help that to cool off. So I'll be back in a couple minutes. We'll get that mass. Okay, so about 2 minutes has passed for cooling. So I'm going to move that crucible now to our electronic balance, and we will determine the mass of that. So a little bit more than 17.5 grams. Then what I've already done is I've taken a strip of magnesium. Magnesium is the 12th element, and I've taken about a 35 centimeter piece of that, and I've just initially wrapped it around kind of a pencil and made a coil shape out of it. So this hopefully will increase the amount of surface area that will be available to react. So I'm going to just put that right inside the crucible. Try to write it here. It's harder than you might think. And so the mass now is obviously increased due to the mass of that magnesium. So what we're going to do next is we're going to heat that gently on our ring stand with our burner. So I'll put that in there and I'll put the cover on. And then we'll get the burner going and we'll heat it gently. So I'll be right back with you. Okay, so now we will heat this gently. And to do that, typically what I do is rather than trying to set the heat to a particular level, typically I'm going to just alternate the heat. This one is a little less sensitive than it will be towards the end of the experiment when you're trying to evaporate the water. But the goal is to try to start this reaction going. What we don't want to do is really to just ignite the magnesium. We want to try to react it in a controlled way so that we're not losing any matter here. If we burn it very quickly, there'll be some of the matter will be released in kind of a particulate form. You would call it smoke maybe. So we're going to be very deliberate to do a slower reaction than you would maybe ordinarily do if you were just trying to observe magnesium burning. And I'm sort of slowly maybe increasing the time that I'm heating it. And decreasing the time, maybe removing the heat. And again, none of the times are super precise here. They're more guidelines than anything else. You really have to base what you're doing off of what's happening. No two experimental setups are typically identical. So you really have to adapt to the situation and the conditions that you have. So now I'm just going to heat this strongly. Now to do this correctly, we need to, as I mentioned earlier, allow for the air to enter the crucible. So the goal is to have kind of a small opening. And then we heat it strongly for about 10 minutes. Now if I come around and show you, hopefully, what this looks like. What you should be able to see through that crack is the magnesium turning red and glowing as it is reacting with the oxygen and the nitrogen in the air. Certainly the crucible itself will become red hot as its temperature is increasing to the point where it will start releasing some of that energy in the visible portion of the electromagnetic spectrum, primarily in the lower frequencies where red and orange are dominant. Obviously also a lot of infrared. It is hard to make this out on the camera, but I can see myself that it appears to be reacting really nicely. So we will let this go, like I said, for around 10 minutes, and then we'll check on it then. Okay, so this has had some time to cool now, which means it should really be something I can touch at least the top of it and not get a burn or anything. So when we look inside, we see it does look pretty well reacted. And what we're going to do is we're going to just probe that, and we're going to try to see that this all just kind of crumbles and breaks up. And if so, that means it's all reacted, because the properties of the products, which is, again, actually two different things. It's both magnesium nitride and magnesium oxide. So again, what we're looking for is that there are no unreacted portions. And you don't necessarily have to literally crumble every single bit of it, as long as you're fairly convinced that, you know, if you run into any portions that won't, you know, break apart pretty readily when you poke at them, that means, you know, you have to add a little bit of additional time for reacting. So I think this one is a pretty good example. Everything seems to be breaking up. I don't see any silver portions. And so I think we're ready to proceed to the next step. So the next step, you're going to take a squirt bottle, and we need to add water. And we don't want to add any more than is necessary to just cover all of our product. So basically, as soon as that last little island disappears, as it has here, then we're ready to proceed to the next step, which is to boil off that water. So we'll resume here in just a second. So I've placed the crucible back on the ring stand in the clay triangle. And now we're going to heat this very gently. I really can't impress upon you how hot this flame is and how small amount of water that is compared to each other, and how quickly this will boil. So this is a step where you really want to take your time, because it will go from not boiling to boiling over and spattering within a second sometimes. So you're kind of watching for a hint of what's going on inside that crucible. You'll see some of the usual things you'll see with boiling. Right now I'm noticing like just the tiniest little bubbles forming. And maybe I'll take this off and try to show you this. Hopefully not mess it up at the same time. But it is so easy to boil over, which of course not only is messy and potentially harmful, nobody wants hot spatter on them, but also you're going to lose material. See if I can zoom that in a little bit. You can see just how little it takes for that to boil. So I'm just going to keep doing this, and once I've gotten all of the really visible liquid removed, I'm going to then be able to heat it strongly, but not until then. So I'll be back at that point. So I've gotten it pretty much to the point where there's no standing water, it's still moist. And when I pass the heat over it, you kind of don't hear any sizzle or anything anymore. And you can see I did a pretty good job. It took a while. This might have taken 5 to 10 minutes. And there's a little bit of spatter here, but not too bad overall. So now we can heat it strongly and completely dry it out. And that should go pretty quickly, just a minute or two probably. Then we'll have to repeat this process. Again, what are we doing in this step? The atmosphere here on our planet Earth is made of both oxygen and nitrogen, and a few trace elements of other things, but those two, and both of those will react with the magnesium, both the nitrogen and the oxygen. But we only want magnesium oxide to remain at the end. So we will react all of the product with the water, and the magnesium nitride will react with the water, and one of the products it will produce is ammonia, and the ammonia comes off and it gives off a fairly characteristic smell. If you've ever smelled it once, you recognize it right away. That being said, it doesn't exactly smell the same way that ammonia would, like from a cleaning product, like maybe Windex or something like that does. When it's heated, it changes the aroma a little bit. So anyway, that's why we do this, and we want to do it twice because we wanted to try to eliminate all of the nitrogen from our sample as much as possible. So we will heat this strongly a little bit longer. We'll repeat that water step. I don't think I'll necessarily show you that. It's exactly the same as before. And then we'll be able to get our final weight after cooling it at the end. All right, so I've done the second water step. I've added the water to cover, heated it gently so as not to boil it over. And again, really not a whole lot of spatter here. If you've ever seen it go really wrong, it's a real mess. And then I finally heated it strongly, and now it's going to be ashy, like you might expect. So I've then let it cool, and we'll check the mass on our electronic balance. So about 18.64 grams. So at this point, you can dispose of the product that's been formed per instructions of the lab and your teacher. Wash the table, clean up, generally put the materials back, and you're done. And then on to the analysis of the empirical formula. So hopefully you found these videos to be informative, not the same as, of course, doing it yourself, but hopefully the next best thing. Thanks for watching. Take care.